Hi again. Okay, today we're going to work on interpretations a bit by working through the answers to one of the exercises in the textbook. So the solutions manual that's posted on Canvas does have answers to the exercise we're going to work on, but those are maybe not all that informative about how you get the answers. Okay, so I'll work through some of these with you. The exercise we're working on here is exercise C from chapter 28, Truth in FOL, from your textbook. The way that question is structured, it says, here's an interpretation given by means of a diagram. And then it gives you a list of 12 sentences in FOL. And you're supposed to say, of each one, whether it's true or false in that interpretation. Okay, so I'm going to walk you through most of these. Not all of them. I want to leave some of them for you to work on by yourself. So we'll do the odd-numbered ones. Okay, let's start at the beginning. First sentence we're looking at is this one. There exists an x such that Rxx. Oh, one thing I should say. Notice all of these sentences have no names. None of them have a name. There's only variables here. And there's only one predicate other than identity. Right? The only predicate other than identity that appears here is the two-place predicate Rxy. Now, you remember our rules for using a diagram to give an interpretation. When you have a two-place predicate, we represent that with arrows. So the fact that there's, for example, an arrow from object 1 to object 2 means that a sentence saying R12 is true. So I'm going to read something like Rxy as saying X points at Y. Okay. Remember also from our conventions for using diagrams, the way you say in a diagram how many objects are in your domain, which objects are in your domain, is just by drawing things like, so the example I used on the whiteboard used stick figures. Sometimes we'll just use little dots. So if I want to say I have an interpretation with two objects, I'll write two dots. So that way I can draw arrows between them, or I can circle some of them if I have a one-place predicate to interpret. Okay, what's happening in this diagram, instead of dots, we have numbers. So this diagram says we have a domain of 5 objects, and we're going to call them 1, 2, 3, 4, and 5. Okay, that's all we need for our interpretation. There were no names in the sentences that we're interpreting. The only predicate is the two-place predicate Rxy, so all we need is a domain, in this case 5 objects, and arrows to interpret the two-place predicate. All right, first sentence. There exists an x such that Rxx. Okay, so hang on a second. I swear I know what I'm doing. I'm good with computers. Let's just clear that out. Okay, so the sentence we're doing is x Rxx. That's got a existential quantifier in front of it. Okay, the general rule for checking whether a sentence whose main logical operator is an existential quantifier, checking whether a sentence like that is true in an interpretation, is you do the following sort of thing. Okay, so the existential quantifier, the backwards E, always will have a variable right after it. So those two symbols together is what I'm thinking of as the quantifier. This is telling you, look at the thing that comes after me, in this case Rxx. Look at the thing that comes after me. Look at the gap labeled with the variable that's part of the quantifier. Okay, find all occurrences of that variable in the thing that comes after the quantifier. I'm saying there's at least one thing from the interpretation such that if you put a name of that thing in both spots, in all the spots labeled by this variable, then you'll get a true sentence. Okay, the official textbook version of how we apply that rule is when I want to check whether this sentence with an existential quantifier on, when I want to check whether that's true in here, the way I do that is by checking whether a different sentence is true in a different interpretation. Namely, I'm going to drop the existential quantifier and just stick with the thing that comes after it, but I'm going to replace the variable x from the quantifier. I'm going to replace that. If I can make this, let me write some text. I'm going to replace that with some name that I haven't used before. Okay. So in this case, I'm going to go from the sentence exists x rxx to the sentence raa. Now, our original interpretation has no way of telling me whether this sentence is true because it doesn't tell me anything about the name a. That doesn't appear here. Okay, our rule for checking whether the original sentence is true in the original interpretation is look at this different sentence, and we're going to look at all the different ways I could change the original interpretation by adding this name. So I'm going to try putting the name A on object 1 and see if RAA is true. I'm going to try putting it instead on object 2 and see if RAA is true. Same by putting A on 3, on 4, on 5. Okay, I'm going to check whether this sentence is true in each of those 5 interpretations. Now, because we have an existential quantifier here, I just want to know, is RAA true in at least one of those 5 interpretations? If it was a universal quantifier, I'd be asking, is it true in all 5? Okay, so here's the answer I get. Okay, I can try putting A on number 1, number 2, 3, 4, or 5. These are the 5 cases I'm checking. Well, if I put the name A on number 1, then RAA says that 1 points at 1, which indeed it does. So I know that if I put the name A on object 1, then RAA is true. But if I put it on 2, then RAA says 2 points at 2, but there's no such arrow. So in that case, our sentence would be false. Likewise, there's no arrow from 3 to 3, no arrow from 4 to 4, but there is an arrow from 5 to 5. So here are the things I've checked. Okay, the replacement of the original sentence with a sentence where you take off the quantifier and put a new name in for the variable, that replacement sentence is true in, well, 2 of the 5 possible interpretations we could get by adding that new name. Okay, 2 is, there's at least one that's true. In fact, there are 2 cases where it's true. So that means the original sentence with the quantifier is true in the original interpretation. Okay, if we look at the second, I know I said I'd do the odd-numbered ones, but let's look at sentence 2. Sentence 2 looks just like the one we just did, but instead of a universal quantifier, instead of an existential quantifier, it's a universal quantifier. For the universal quantifier, I do the same kind of test. I'm looking at the same replacement sentence in the same batch of 5 augmented interpretations, modified interpretations where we add in the name A. But instead of asking, is at least one of them true, I'm asking, are they all true? Because the universal quantifier says no matter what you put in for X, you'll get a true sentence. In this case, that's not true, right? There are some cases where the object points at itself, but there are some cases where it doesn't. So that means this universally quantified sentence is false in the original interpretation. Okay. That's how we deal with quantified sentences in an interpretation, how we check whether they're true. All right, let's do a different sentence. Let's take a look at number 3. Okay, now we've got multiple quantifiers, so things are getting extra complicated. So we have existential quantifier X, universal quantifier Y, y are xy. Let me draw in the quantifiers. So existential x, universal y are xy. All right, how do I check whether this sentence is true? Well, we apply exactly the same rules as before. So the main logical operator here is that first quantifier, the existential x. So that's telling me, take a look at what comes after the quantifier. Okay, I'm going to look at a replacement sentence that we get by dropping the existential quantifier. And now I'm going to look at the result of putting a new name in for x. For all y are a y. That's what we get by dropping the existential quantifier and replacing all of the x's. There's just one x, replacing that with a new name. Okay, and now I'm going to check those same 5 cases. I'm going to try putting a on object 1, then I'll try putting it on 2, 3, 4, 5, etc. Okay, now how do I check whether the new sentence, universal y are a y, how do I check whether that's true when, let's say, a is on 1? Well, now I apply the rule for the universal quantifier. That rule says, look at the variable in the quantifier, try replacing all occurrences of that variable in the thing that comes after it with a new name. Try all the 5 options for where you can put that name on our interpretation and check whether all of them are true. Okay, so if I drop the quantifier and replace all occurrences of that quantifier in the remainder, the thing that comes right after the quantifier, replace that with a new name, well, then I need so I drop the y, I have r-a-y, but now I'm going to replace that y with a new name. I can't use a again because I've already had that. I'll pick another name, b. And now I'm going to check all the 5 places where I could put b. So here's what happens. While I'm checking whether for all y, r-a-y is true when I put a on 1, I'm going to keep the a there, and then I'm going to try all the 5 places where I could put b. So I could put b also on 1. And then this says 1 points at 1. That's true. Then I'll try putting b on 2. 1 points at 2. That's true. I'll try putting b on 3. 1 points at 3. That's true. 1 points at 4. That's true. 1 points at 5. That's true. So when a is on 1, anywhere I put b, I get true. So that tells me when a is on 1, for all y, r-a-y is true. On the other hand, what if I put a on b? Oh, sorry, on object 2. If a is on object 2, well, if I want to check whether for all y, r-a-y is true, I check the 5 cases of where I could put b. Does 2 point at 1? No. Does 2 point at 2? No. Does 2 point at 3? No. Does 2 point at 4? Also no. Does 2 point at 5? Yes. Now, the test I was doing was universal. I wanted to find out, does 2 point at everything? The answer there is no, it doesn't. There's only one thing it points at. So when a is on 2, we get false. For all y, r-a-y is false if a is 2. If a is 3, again, 3 doesn't point at everything. 4 doesn't point at everything. 5 does not point at everything. So if I'm checking this sentence for all y, r-a-y, that is true only when a is 1. It's true when a is 1, it's false all the rest of the time. But the reason I was checking those 5 cases of that sentence for all y, r-a-y, that was because of an existential quantifier. So I just needed at least one of these 5 things to come out true. And I have that, right? As long as a is on number 1, we get true here. So that means the original sentence in the original interpretation with no names, the original sentence is true. Right, so that's the answer for number 3. That's how you get it. Okay, let's do number 5. I said I'd do the odd numbered ones. Number 5 says this. Okay, we have a whole bunch of quantifiers now, 3 of them. But in a way, this is actually going to be simpler than the last one we did, because even though there are more quantifiers, there are 3 of them instead of just 2 in the other, what you'll discover when you work on these problems with multiple quantifiers is multiple quantifiers are complicated when you have a mixture of existential and universal, and then you have to be very careful and pay attention, importantly, to the order they come in. But when you have a mix of just universal or just existential, things get a lot simpler. In fact, you'll find it doesn't matter what order you look at the quantifiers in. So for all x, for all y is going to work out the same as for all y, for all x. Effectively, when you see 3 universals in a row for x, y, and z, they're just saying pick any 3 things you like. So I'm going to skip some steps as we work on this, just to simplify how to think about it. Okay, rxy and ryz, arrow rxz. Okay. And we have universal, universal, universal. I should figure out how to type an upside down A. Okay. This is the sentence we're worried about. So here's how I think you should read this. This says, because you've got 3 universals in a row, this is saying no matter which 3 objects you pick, and by the way, you can pick the same object for x, y, and z. They don't have to all be different. They can be. They don't have to be. For any 3 objects you pick, this sentence is going to come out true. So here's how I want you to think about that. Just like before, we are going to drop the quantifiers and replace the variables with new names. And what we're going to examine is the result of taking this sentence, dropping the quantifiers, and putting names in for them. So instead of x, I'm going to pick the name A. I can use that because I haven't used it before. At this point, I haven't used any names. Instead of y, I'm going to use, well, I can't use A because that one's shown up now. Let's call it B, and we'll use C in for Z. So we are going to look at the sentence RAB and RBC arrow RAC. What I want to check is for each of the places I could possibly put the names A, B, and C, is this sentence going to be true? Now, when I check whether this sentence is true, I have to use a truth table, right? We've got truth functional connectives here and an arrow. Now, if we do a truth table for something of this form, A and B, arrow C, I'll leave you to figure this out for yourself, but the only line of the truth table where that sentence comes out false is where A and B are both true and C is false. Actually, sorry, I'm using lowercase a, b, and c as names up here, and you can't hear the difference between them when I talk, so I'm going to call these P, Q, and R. So P and Q, arrow R. The only way for that to go false is for P true, Q false, and R false. So I want to look and see, can I put the names A, B, and C on this diagram so that I get that pattern here, so that I get true, true, false. Okay, what does it mean for each of those things to be respectively true, true, and false? Well, so I want to find A, B, and C so that A points at B, B points at C, but A doesn't point at C. Okay, I'd like you to pause the video now and see if you can figure that out for yourself. Take a look, see if you can find where you could put A, B, and C to make A point at B, B point at C, but A not point at C. And now I'm just going to give you the answers, because hopefully you pause the video and look for yourself. Okay, there are a few places where this goes false. And because we started with universal quantifiers, it's enough for us to find even one set of 3 objects that make this false, because this says it'll always be true. So if it's ever false, we're done. Okay, let's see. Here's one you might have found. If I put A on 4, well, 4 points at 1. So if I put B on 1, then our AB will be true. Okay, 4 points at 1. Now, what's something that B points at? What's something that 1 points at? Well, 1 points at 3. So our BC is true, but our AC is false because A doesn't point at C. Okay, you could have also picked 2 for your C. Okay, so those examples, there are several others. Examples like that would be enough to show that the original sentence is false, right? Because I can fill in the X gap, the Y gap, and the Z gap so that this sentence in the brackets comes out false. But let me give you another example of where you could put A, B, and C that you might not have noticed. So let's again pick A for 4 and B for 1. Pick 4 for A and 1 for B, whatever. Let's put A and B where they were before. What happens if I also put C on 4? Again, I told you, there's no rule that says when you've got these quantifiers, you're not allowed to put the same letter, the same object in multiple gaps, right? You absolutely are. When you see different variable letters, that means you're allowed to put different objects in the different gaps, but it doesn't mean you have to. When you see the same letter, it means it has to be the same object. But when you see different letters, it just means you're permitted to put different ones. Okay, let's check when A and C are both object 4 and B is object 1. Well, RAB, does 4 point at 1? Yes. RBC, does 1 point at 4? Yes. RAC now says that 4 points at itself. But 4 doesn't point at itself. Only 1 and 5 point at themselves. So this example also shows that the original sentence is false. Okay, let's move on and do another one. Let's go on to sentence 7. Okay, we have a mixture of quantifiers again. So this time our sentence is existential existential X universal Y not RXY. Let me draw in the quantifiers. There exists an X such that for all Y, X doesn't point at Y. Okay, so this says I can find something to put in the X gap so that no matter what you put in the Y gap, this sentence saying X doesn't point at Y is true. So no matter where I put X, that is, if I drop the X out and put a new name in for X, no matter where I put, there is somewhere I can put A that'll make this new sentence true. And this new sentence says, no matter where I put B, this sentence, not RAB, will be true. So I have to check all the 5 cases where I could put A. And for each of those, I have to check all the 5 cases where I could put B. And then I work my way back up. Okay, I need to find at least one place I can put A that makes it so that no matter where I put B, sentence comes out true. Okay, again, I'm going to leave you, I would like you to pause and see if you can find a place where you can put A so that no matter where you put B, A doesn't point at B. And now that you've thought about it, I'm going to give you my answer. Okay, let's see, there are 5 places we could put A. We could put A on number 1, but then the sentence, for all y, A doesn't point at y. In other words, A points at nothing. That's false. 1 definitely points at something. In fact, 1 points at everything. What if we put A on object 2? 2 points at something, so it's not the case that it doesn't point at anything, which is what this says. Right, 2 points at 5, so that doesn't do it. What about 3? Aha! 3 doesn't point at 1, 2, 3. There are no arrows coming out of 3. So, no matter where you put B, if A is on number 3, then A doesn't point at B. So we have something that doesn't point at anything. And that's a way you can read this to yourself. Try reading it from left to right. This says, there is something such that it doesn't point at anything. There's something I can pick such that no matter what you pick, my thing doesn't point at your thing. That's a way of reading this. If that's not obvious to you, don't worry. The way you learn to read these things, sentences in FOL, is by practicing with interpretations. Just figuring out what a sentence says by going through all of these steps. That's how you get used to it. And the more practice you get, the sooner you'll start just reading what they say. Okay, let's do number 9. Now we have identity. Okay, we have multiple quantifiers, but both quantifiers are existential. That simplifies things. Just like when we had multiple universal quantifiers, right? For all x, for all y, for all z, that basically says pick 3 things. No matter what they are, this sentence will be true. When you have exists y, exists x, that's saying there's some 2 things you can pick. Doesn't matter what order you take them in. There's some 2 things you can pick that'll make this sentence in the brackets true. So existential x, existential y, bracket, open bracket, not x equals y, and rxy and ryx. That's our sentence. Okay, let me draw in the quantifiers. Exists x, exists y. This is number 9. Okay, what does this sentence say? It says, I can find 2 objects, or possibly just 1 object. I can find objects to put into these 2 gaps. Right? Again, having different variables doesn't mean you have to pick different objects, but I'm saying there's some things, some places I can put objects A and B that make this sentence true. Right? That's the result of taking the thing in the brackets, dropping the quantifiers, taking the thing in the brackets, and replacing the variables with some names that I haven't seen before. So, what are we saying here? We're saying I can find objects A and B such that A is not identical to B. Remember I said, as far as the quantifiers are concerned, you're allowed to put the same object in for X and Y. But our identity sentence tells me, well, if you put the same object in as both X and Y, both A and B, then we're going to get something false. Because this sentence says A is not the same thing as B. And that's joined up with the other things by ands, which means I need to make all 3 of these things true. Okay, so I'm looking for 2 different things such that A points at B and B points at A. Can you find places to put, let's say, A and B so that they're on different things, but you get arrows in both directions? I'm not even going to ask you to pause. I bet you can find one. That was my way of suggesting you could pause and see if you can find them. But look, try putting A on 1 and B on 4, or the other way around. Well, 1 points at 4, 4 points at 1, so we get A is not identical to B. That's true. 1 and 4 are different objects. A points at B, 1 points at 4. Yes, it does. B points at A, 4 points back at 1. Bingo. Okay. There is something, there is somewhere I can put the names A and B that make this sentence with names true. Since there's at least one pair of objects like that, that means this original sentence with the existential quantifiers is true. Okay, so that one is true. Let's do number 11. This is our last one. I'll just display number 12 as well so you can see what we're working on. Okay, number 11, we have mixed quantifiers again. Those are the tricky ones. So existential x, universal y, r, y, x, biconditional, tricksy, x equals y. Okay, what does this say? Let me draw the quantifiers in. Existential x, universal y. Okay, so let's do it step by step. When you've got mixed quantifiers, some existential, some universals, I think it's a very good idea to slow down, go step by step, because, as I said earlier, those are the cases that are extra complicated. So here's what we have. Existential quantifier on an x that applies to this whole thing. That means, in the first instance, we're checking for all the places I could put a name A, is this sentence true? I'm going to check all the places I could put A, and I want to make sure, because this was an existential quantifier, I want to make sure at least one of them comes out true. And what I'm checking in each of those 5 cases, A could be on 1, 2, 3, 4, 5. What I'm checking in each of those 5 cases is whether this universally quantified sentence is true. So what I'm doing is taking the thing that comes after the universal quantifier and putting a new name in for the variable, which in this case is y. So I'm checking whether RBA biconditional, oops, this should be A equals B, checking whether that thing is true. Okay, so once I pick a place to put A, let's say object 1, I'm checking all the places I could put B, and I want to make sure that this comes out true for all of them, all 5. Okay. What am I checking here? It's something that has as its main connective a biconditional. So that means there's 2 ways, just from the truth table, there's 2 ways that this could be true. Either both sentences, both of the atomic sentences here are true, or both of them are false. Okay. The biconditional says you have the same truth value on either side, right? So either both true or both false. So let's just go through step by step. Suppose we have A on number 1. Is it true that no matter where I put B, these 2 things are either both true or both false? Well, suppose B is on 1. Then, let's see, RBA, that comes out true. Does B point at 1? Yes, it does, because they're both 1 and 1 points at itself. Is A identical with B? Yes, it is. So we have true, true, success. What about if I put B instead on number 2, keeping A on number 1? When B is on true, well, RBA, that's false. B doesn't point at A. Notice that the sentence is RBA, not RAB. RAB is true, but RBA is false. Okay. A identical with B? False. What about if I put B on number 3? On number 3, well, RBA, that's false. A identical to B, false again. So far, all of my cases have come out true for the biconditional sentence. When B was on 1, we had true, biconditional, true. For 2 and 3, we had false, biconditional, false. We're doing okay. What about, though, if I put B on number 4? Now RBA is true. 4 does point at 1. But A equals B is false. 1 and 4 are different things. So we have true, biconditional, false. That's false. I don't have to check number 5 now, because the reason why we're moving B around is for this universal quantifier. Universal quantifier wants to make sure every case is true, but I just found one where it's false. So that tells me when A is on 1, this universally quantified sentence is false. Okay. Let's do the case where we put A on number 2. And I'm going to spell this out even more. Let me add another list of cases we can check. So now we're checking when when A is on number 2, and I'm checking one by one all the cases of where I can put B for when A is on 2. So first of all, we put B on number 1. Then we find RBA, that's true. 1 does point at 2. A equals B, that's false. B is not 2. So that means I have true, biconditional, false. That means in the case where B is on number 1, we get false. Now, because on this list I'm checking for a universal quantifier, that means I'm done, right? I wanted to know when I put A on number 2, then am I going to get true for all 5 cases of where I could put B? And I already know I don't. No matter what happens with 2, 3, 4, 5, no matter how I move B around, I know that if B is on 1, I get a false sentence here. So we're done with that case. I know that if A is on 2, the universally quantified sentence is false. Okay, let's try putting it on 3. Suppose A is on 3. So now the case we're checking is this one. Okay, we have a bunch of places we could put B. Well, if I put B on number 1, then RBA, true. A equals B, false. So case 1, already false. So I already know I'm done. I don't have to check any other cases. The universally quantified sentence is false when A is on number 3. So let's try it on 4. If A is on 4, again, 1 points at 4. That's a problem. 1 points at 4, so this is true. 1 is not 4, so this is false. So we have true, biconditional, false. It's false again. Sad times. So it's false when A is there. Finally, suppose we put A on number 5. Still, 1 points at 5, so if I put B on 1, I get true, biconditional, false, because B is not the same thing as A. So, sorry, I just had a moment there of not being sure I was right. Okay, so again, we're going to get false. Okay. This is what I get for checking all the 5 places where I could put A. I got false in every case. That means the original sentence, I only needed one of them to come out true, but none of them did. That means the original sentence in the original interpretation is false. So the sentence that has quantifiers, no names, in an interpretation that has no names on it, that comes out false. Womp womp. Okay, that's how you do it. That's how you check these things. Go try the rest of them. See if you can get them. The rest of the sentences from this exercise that I didn't do. You have solutions in the textbook, in the solutions manual posted on Canvas, so you can check whether you're getting the answers right. If you get stuck, send me an email. If enough of you get stuck on the same thing, then I'll do a video. But that's enough for today. Talk to you soon.